Okay, this is the activity for week 12, the chi-square distribution week, and it involves M&Ms. So what you need to do this is about 30 M&Ms. I have M&Ms on my door, so you should certainly come by my office and get some fun-sized packs if you'd like to do that. If you're quarantined, you should get a friend to do that for you. My office is Violet 2132, about halfway around the math side of the building. If you're home, if you're somewhere else, if you just can't get to my office, or if you get there and there aren't any, just get yourself some M&Ms. I have 3 fun-size bags for each person because that gets you about the right number of M&Ms. But if you buy a medium-sized bag, you can easily get 30 or 40 M&Ms out of there. And of course, you're allowed to eat all of them because they're M&Ms. Then what you're going to do is you're going to open them up and count them. So on the shared doodle page, I just have a sheet where we're going to count M&Ms, and it's called M&M handout. And I also have some of these sheets outside my door that you can get with the M&Ms. Anyway, you're just going to open up your packs of M&Ms and you're going to count them. Now, when I do this in class, I normally tell funny stories about M&Ms because M&Ms are awesome. But you can just go ahead and do it and pause this video and restart it. I'll just tell you one quick story, which is that the largest purchaser of M&Ms in the United States is the US military. I'm sorry, the largest purchaser in the world is the United States military, because it is true that the M&Ms actually do last longer than other candies. They melt in your mouth, not in your hands, which makes them really good to put into MREs or C rations. And for over 50 years, M&Ms have been really commonly put in those stored rations that you have to use. And there's a story, which again, I don't know if it's true, but that every military airplane has M&Ms in the seat in case there's an ejection, because if a pilot ends up behind enemy lines, they're going to need energy fast, and M&Ms are a really good way to do that. And because they do last a long time, they're good to put there. You only have to change them out every once in a while. Is it true? I don't know. Anyway, if we were in class while you're counting M&Ms and eating them, I would tell you other funny stories from when I called the M&M company and I got information from them. Look at that, all the healthy things you get. And they sent me a brochure and stickers and all kinds of stuff and really good coupons and things. But anyway, go ahead and pause this until you have counted your M&Ms. And again, you should have about 30 of them. And when you do, you can just enter them on the sheet. Now, the doodle page, you can't write on it, but just make a copy of it, and then you can write whatever you want on it. So anyway, go ahead and pause that and I will wait. Okay, welcome back. So hopefully you should have your M&Ms counted. Again, I already put mine in like we're on a cooking show. I have my M&Ms right here. You can see how many there are. And it's about 30, and I'm going to eat them while I talk to you about how to do the next calculations. So in the 11.1 video, which I think you should have watched by now, we talked about how if you can figure out what the expected number is and the observed number, we can use this formula from chi-square and figure out what how we're gonna calculate that. So I have the proportions for plain M&Ms right here, 13% brown, 14% yellow. Notice they're not evenly distributed across colors. There's a particular distribution. When I called the M&M company, another story, they actually have a person that they put stats people in talk with, because many stats professors use M&Ms in their class, because how else are you going to count things? And I mean, really, you can really get a sense of how you're counting things. Anyway, they use focus groups to figure out what colors kind of look the most joyous and which ones people like the best. And they have actually changed over time. And when I first started teaching in the early 2000s, the proportion was different. And they did connect to that. Anyway, they're a little bit different. So you probably wouldn't be surprised if I said, hey, there's 100 people in my study, and of those, 60% are women. If I said, how many do you think will be women? You would say, oh gosh, 60% of 100 is 60. Well, that's the calculation we're going to use here. And again, if you wanted a formula, the idea is the expected number of a particular color is going to be equal to our overall count times the probability. Oops, okay, my bad drawing aside. That is the formula that we're going to be using for that. So we're on a spreadsheet, so we don't need to do too much thinking here. And we just say, well, if there are 13% are brown and there are 31 M&Ms altogether, we're just going to take 31 times 13%, and that gets the number of about 4. Now you can already see where we're going with this, that if we say, well, we expected to have 6, but we had 4, well, our difference is going to be 2. And the question is whether or not that's enough that we really think there's a statistical difference, or is that just enough that random chance would do that? Well, now that we're all up on the concept, we can go ahead and do this. When I do this in class, I actually have you work this out by hand because it's totally a thing you can do with a calculator or whatever, your phone, as you do that. Well, anyway, I'm going to just drag it down, and because I put the $ in, that's going to work out, right? So this one is going to be 14% times 31 and 13% again. That's the same number. 24%, there's more blue M&Ms on average, and 31. If we did it right, this number should add up back to 31. And sure enough, it is. So now we can calculate the difference. Remember, the goodness of fit test uses observed minus expected squared divided by expected. So observed minus expected, well, that's just subtraction. Observed minus expected, it's about 2. Here it's going to be what, 1.3 or whatever, minus. Here this one's off by about 1, and so on. Notice that the green ones are off by a lot. Okay, well then back to the formula, we're going to square it. Well, that's easy. We just use that little square doodad. That thingy, caret 2. Let's us square it. 2 squared is about 4. 6 squared is about 36. Notice that gets us all positive numbers, just like on my cool and awesome chart. And that is the top of our fraction. So just like we had x bar minus mu, here we have x bar. No, we don't have x bar, we have O minus E squared. We're going to divide that by E, and again, that's just dividing. O minus E divided by E, and that gives us 0.96. And then we're going to drag that down, and that gives us our calculation. So you can see again that green gives us a big difference, right? That's a big contribution to our error. These two right here are very close, so they give us almost very little to it. We add them all together and we get 13.267. If you remember from the chart we had before, 11.070 was our critical value, just like we had 1.96 when we were doing it with Z. We have 11.07 to do it with chi-square. So if our number is bigger than 11, we would put it in this proportion. Now, we got 13.267. 13.267 is larger than 11. So that tells us that the difference is significant. So for my particular M&Ms, yours will be different because you're going to do the math with your numbers. For that particular number, you're going to get the value that you have. So what's weird is that we would expect this to happen about 5% of the time. And I had it happen with me. So you're like, well, that could happen. But it turns out when we do this in live class, about 3/4 of the class actually reject the null hypothesis. And that's weird because you're like, well, so what is it? Is the M&M company, are they liars? Well, when I called M&M, don't make me pull up my cool folder again. When I called M&M, they explained how they make M&Ms. So M&Ms are made in a giant vat, and the giant vat makes one color at a time, and then it gets mixed in this big cylinder, and then they come out the bottom and get packed. And the cylinder is so big, it's about 5 meters across and about 3 meters deep. So it's 10 feet deep. So you can imagine it's like a little swimming pool. So now you could pause it if you need to imagine swimming in a pool of M&Ms. But what that means is they make one color at a time and then they mix it. And whatever color they're about to make, they're going to be short of that color. And whatever color they just made, they're going to have a few extra. And even with mixing, one color is going to be overrepresented and one color is going to be underrepresented. And when they called me and told me that, they said that you should expect that most all the time. And because we all have the same M&Ms, it's likely that you're going to have the same extra and light color that I did. And I mean, it doesn't take too much math to look at this and say, well, look, here's the big contributions. Green was overrepresented in mine and blue was underrepresented. So I should have had 7, but I had 3, and I should have had 5, and I had 11. The other ones are actually pretty close, right? 6 to 3, 4 to 5, 4 to 3, right? That's off by just a couple. Those 2 colors are off by a bunch. And that is what we see when we do M&Ms. And like I said, when I called them, that's literally what they told me to expect, which is pretty cool. All right, so if we want to do this automatically, I'll show you how to do it first here in Google Sheets, and then we'll go to StatCrunch to do that. Back to my mouse, there we go. So I made another tab over here called Chi Goodness of Fit, GOF. And I put these categories here, but you can use whatever categories you want. So you just put your observations here. You do the calculations here, just like we did before. Then I did the whole formula all at once. So observed minus expected squared divided by expected. For whatever problem you're going to do, you can change this proportion. So if you want it to be 50% men, 50% women, or 25% freshmen, or whatever homework question it gives you, you can do that. Then you have your observed, and then you have your expected. Now you can do what I did here and calculate it and get it. Chi-inv is the command in Google Sheets that looks up the number on the table for you. Again, 11.7 is ours. But even better than that, there's a command called chi-test, where you literally just click on it and you put in the observed range and the expected range. So here, in this case, it's C2 to C7, D2 to D7, and it does all the calculation for you, and what it spits out is a p-value. It's a little bit weird because it uses scientific notation, but if we turn that back to a regular number, whoop, it would give you 0.02. So we'll get 0.021. That's a p-value. So instead of just saying 13 is bigger than 11, we can get the exact p-value for our value. So in this case, 2%. Remember how to interpret that. If our hypothesis was correct and those proportions from M&M were right, we would expect to get data like this 2% of the time. Now you might say, you just told me that they didn't lie about the percent, right? So the assumption that failed was the assumption of a simple random sample, because of that way they mix the M&Ms, the sample isn't actually very good. And so that's how they get M&Ms to do that. All right, let's go to StatCrunch now. StatCrunch. We can sign in. Oh, right, sign in. Here we are. I'm just going to go ahead and copy our proportion and our observed, just so we don't forget what they are. And here it is. Oops, and there's my old lab. Let's go to a new data table. And I'm going to copy my values in here. I'm actually going to also copy my colors so I don't forget which one is which. We would call these data labels when we're doing statistics, but they're colors. All right, we're going to go to stat. We're going to go down here to goodness of fit. We're going to do the chi-squared test. Our observed is in the column I marked observed. The expected is in, oops, the proportion. So I didn't want that one, I wanted the expected one. Joop. Cancel. Expected. Okay, let's run it again here. Goodness of fit, chi-squared. Our observed is in the observed, our expected is in the expected. It'll display whatever we want. The standardized residuals, we can get that if we want. Boom, it's going to go ahead and do that calculation. The standardized residuals is this number right here from what we got. Again, the p-value is 0.021. and we're good to go. So that gives us our chi-square value. Okay, so if what you have is observed and expected, you can just put them in the columns there. Now, if you did want to check whether or not the colors were just equal, that was one of the options there too. We can say observed all cells in equal proportions. And then we get the value. Notice in this case, all cells in equal proportion actually fits better than what we have. Some years it's actually much worse than that. Okay, so I hope by now you've eaten half your M&Ms like I just did while I was talking to you. If not, and eat them whenever. If you don't like chocolate, sorry, you had to do this. All right, so that is our last activity. You are going to have to turn a little bit in order to get your attendance points, since nobody's going to attend because this lab is totally virtual. But if you turn that in, we should be good to go. So, all right. I think it is better that we went this lab virtual because sitting there eating M&Ms without our masks on would be sort of troubling this semester. So sorry, we're not going to have our last lab live, but I'll see you all on the at the exam, December 8th at whatever that was in the afternoon. We'll give that information to you some other way, but I'll see you at the final exam. If you have any questions or anything, as always, please do drop me a line, send me an email, and I hope to see you soon.